This is Unit 2, Day 8 Note Guide, where we are proving angle relationships. As you can see on this proof, it's half filled out for us, and our given is that angle 1, this angle right here, is congruent to angle 3. So our first statement then is pretty obvious. That's just going to be a given. That's listed up here. Okay, so we've got everything checked off from our givens down in our proof. So now we can start our proof. If I'm looking at step 2 here, I'm seeing step 1 and step 2, and they look pretty similar. The only difference is that one of them is in the equal sign language and the other one's in the congruent sign language. Right here, we are basically changing languages. And our name for changing languages that we have is definition of congruent angles. Remember, if it was segments that we were talking about, we would call it definition of congruent segments. That also changes us languages. But those are basically our two language changers. And again, I just want to mention this one more time. We could also use definition of congruent angles going backwards. So as you can see at the end of the proof, I'm just going to give us a little hint here. We'll talk about it then when we get there. But we're changing languages here as well. We're changing languages from an equal sign to a congruent symbol. So we're going backwards. So up here we go from congruent to equal, and then down here we go from equal to congruent. That means 5 and 6. We're probably going to be using that definition of congruent angles once more. Let's go on to step number 3, though. I see measure of angle 1 plus measure of angle 2 equals measure of AEC. Well, that should make sense. Like this angle plus this angle equals the big angle, right? If we do little angle plus little angle, that's not new to us. That would be called angle addition postulate. And they just did one line for number 3 because it's the same thing for both of these. This is angle addition postulate, and so is that one. Number 4. Okay, so we've got measure of angle 3 plus measure of angle 2 equals AEC. What are they doing here? Well, it's kind of tough to see, but I actually see I'm seeing substitution here. Here's what I'm seeing. If I look at the first line of step 3 and I bring it down here, they look pretty similar. Like they're both equal to measure of AEC. They both have the measure of angle 2. The only difference is right here, measure of angle 1 and measure of angle 3. Now, why would we be able to change that? Well, because we set up here measure of angle 1 equals measure of angle 3. So the only big change is they took this out and they put measure of angle 3 in. So that's our big change. That is substitution property. So that would be number 4. Let's continue to number 5. What's happening down here? Well, now they're seeing, I can see that they've got measure of AEC and measure of DEB set equal to each other. They can do that because if you look here, we've got the same thing. So the second line of number 3 and the number 4 here have the same thing on the left-hand side, and they're equal to different things. So these two things can be put down here and set equal to each other as well, because these things are the exact same right here. Since those are the same, that means these are the same, and that's how they wrote them down there. So how would we write that? That would also be substitution property, where basically we know that they are the same, so we can substitute them in and say that they're equal to each other. And then our last step here, like I said before, definition of congruent angles is going to be my reason for that. So because we're changing languages again. Okay, let's go on to number 2. So for number 2 here, what we've got going on is we've got angle 1 and angle 2 being congruent because of our given. DB bisects ADC. So this ray right there is bisecting this angle, and that's why we have our 2 congruent angles. That's why I had my 2 markings listed on the picture beforehand. So obviously that's going to be step 1 for us, and we can put given for that. Oops, I kind of gave away number 2. We got a little hint. I want to mention that on this one originally, we had M's marked down, and then we realized that it's not actually true because this bisect, or I guess I could just say number 2, the definition of angle bisector, if you actually look at the definition of angle bisector, if you bisect something, the actual definition says that the 2 angles are congruent, not equal. So we're not in the equal sign language there. We're in the congruent language. So that's why I wrote M's, and then I scribbled them out because I wrote them in pen. But it should be angle 1 is congruent to angle 2. And that's what we wrote on our picture too. Let's move on to number 3. Okay, so what do we know next? And what are we trying to get to? We're trying to prove that 2 is equal to 3. We're trying to prove that this angle is equal to this angle. Well, how would we get there? If we know angle 2 is congruent to angle 1, let's zoom in on this really quick. We're just going to look at this picture really quick here. We know that angle 2 is congruent to angle 1 because of this bisect, right? That's being bisected. Well, how could we say that 2 is congruent to 3? Well, this is my mind. This is how my mind is thinking. We know that 1 is congruent to 3, right? How do we know that? 1 is congruent to 3 because they are vertical angles, right? So with vertical angles, we can say 1 is congruent to 3. Well, then, if 2 is congruent to 1 and 1 is congruent to 3, then you could say that 2 is congruent to 3, right? So that's what we've got to get to at some point. We're going to be using vertical angles at some point. And let's see how we have this listed here. I think we could use vertical angles next. I know this is one that we don't have either side. So I would probably use vertical angles next. I would say 1 is congruent to 3. That way we could say that 3 is congruent to 2. And that's exactly what happens here. And we would call that vertical angles theorem. The vertical angles theorem says that these would be congruent. Okay, next. Now we said that those were congruent. We can start to say that I think 3 is congruent to 2 now. Because if 3 is congruent to 1 and 1 is congruent to 2, then 3 would be congruent to 2. So now they say 3 is congruent to 2. And that is our substitution property. We can say that substitution, since 1 is congruent to 2 and 1 is congruent to 3, then these things should be congruent to each other. That's why it's substitution. Now, this proof could have been 4 steps long. There was a 5th step added on there. We could have probably just written angle 2 is congruent to angle 3 and been done using substitution. But since there was 5 lines, I wrote it this way just so we could get that extra practice in. So on our 5th line, we'll switch them around. We'll call them 2 is congruent to 3. This is just extra practice because I wanted us to see what is it called when we switch them around. See if you can remember. That's the symmetric property. Hopefully you remember that. Symmetric property is what flips those around. Okay, that's our second proof. Let's move on to the third one. Here's our third proof. Here's what we got. We said 1 and 3 are complementary and 2 and 3 are complementary. We're trying to prove that 1 is congruent to 2. Let's talk about this for a second. I just want to do an example here. So it says, 1 and 3 are complementary. Let's just assume that they are. Let's say that this one is 40 degrees, okay? And we'll say 1 and 3 are complementary. What would 1 have to be then? If this is 40 degrees and complementary means they add up to 90, that means 1 would have to be 50 degrees, right? Okay, so that's where we're set. Now it also says, so that's good. Now we're trying to figure out 2 and 3 being complementary. Well, 2 and 3 being complementary would mean that 2 would also have to be 50. So then we would say that 1 and 2 are equal or congruent if we didn't know their actual measures. So we're trying to prove this without using numbers because we're going to have to use some numbers, but we got to use it without, or we got to figure this out without using the numbers 50 and 40. So let's write down our givens first. 1 and 3 are complementary and 2 and 3 are complementary. And that's our given. Give you a second to write those down. Okay, so now that we know those are complementary, we have to define complementary. That's one of our vocab words in our given, and I've said this before. If you see a vocab word up there, you're probably going to be defining it or using a theorem with it in the name. So for this one, if they're complementary, we're going to use definition of complementary. What does the definition of complementary say? If I asked you to define complementary, you would say you would add them up and set them equal to 180. Or I'm sorry, just kidding, 90. So if we did 90, this is how it would look. We would use measure of angle 1 plus measure of angle 3 is equal to 90 degrees. Okay, we are in that equal sign language. It's okay that we're in that equal sign language. We weren't ever in the congruent sign language up here, so that's okay. We will have to get to the congruent sign language, so we're going to have to use that language changer at some point. We could call it a translator, but we're going to be changing languages probably at the end. Okay, so now the next thing that I'm seeing is that we have two things, right? These two items are both equal to 90. If that's true, if they're both equal to 90, then they should be equal to each other, correct? They're both equal to 90, so why wouldn't they be equal to each other? That's going to be my next step. Now, how can we say that? Well, because if this is equal to 90, we could take this and we could plug it in for that 90. We would plug it in for that one spot, and then we would have measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. We're basically taking this piece and plugging it in or replacing it, and in geometry, we're going to call that substitution property. Okay, now if I'm looking at step 3, let me erase all this stuff. What I see on step 3 is I see we've got the same thing on both sides, those measures of angle 3. We can get rid of them now, and then we'll be really close to what we're trying to prove. If we get rid of them, it'll just be left with measure of angle 1 equals measure of angle 2. How do we get rid of them? If it's the same on both sides, how would you get rid of them? It would be subtraction property. Okay, and then after that, it looks like this is very close to this. That's going to be our last step. I can't draw a star right now, but that's going to be our last step. How did we get from this to this? We just changed languages. This is the definition of congruent angles. That's something that we got to know. And I said this before. This reason is going to be in like 70% of our proofs that we go through in this class. We're going to be changing languages all the time. So definition of congruent angles or definition of congruent segments is a really, really big one that we need to remember. We're on our last one here, guys. Last one. So number 4, we say 1 is congruent to 2 to start. That's our given. And I can even put that in there. That's like 3 points that I gave you right there. That's part of the given. Okay, so if 1 is congruent to 2 and we're trying to get to the point where 3 is congruent to 4, how could we do that? Just by looking at the picture. We want to show that 3 is congruent to 4. Oops, sorry. Let's look at that picture here. So we said 1 is congruent to 2. Well, isn't 1 congruent to 3? Like those two should be congruent, 1 and 3, because they're vertical angles, right? And 2 should be congruent to 4, because 2 and 4 are congruent angles. So if these are all congruent to each other, right, because 1 is congruent to 2, and 2 is congruent to 4, and 1 is congruent to 3, then 4 should be congruent to 3. So basically, this proof, we're going to do a lot of vertical angles and probably some substitution to get to our final answer. Let's see how it goes, though. So 1 is congruent to 2. We already got that. That's given. 2 is congruent to 4. That's like what we said. If 2 is congruent to 4, that's because of vertical angles. So that's going to be vertical angles theorem. Says that those are congruent. Number 3, 1 is congruent to 4. Okay. Obviously, if I'm looking at my picture, 1 and 4 are not vertical angles. But we could say that because of what we have up above. If 1 is congruent to 2 and 2 is congruent to 4, then 1 would be congruent to 4. That's our substitution property. Okay. Second to last step, number 4 here, 1 is congruent to 3. Looking at our picture, if I look at them, 1 and 3 are vertical angles. I think we're using vertical angles theorem again. That's another way to prove that 1 is congruent to 3. There we go, vertical angles theorem. And then our last step, it's what we're trying to prove, right? We're trying to prove angle 3 is congruent to angle 4. So that would go there. How could we get there? Well, I see 1 is congruent to 4 and 1 is congruent to 3. So that means 4 should be congruent to 3, or 3 is congruent to 4, if that's how you want to say it. And that is our substitution property because of lines 3 and 4. Okay, I hope that makes sense. That's it for this lesson. Thank you for watching.